Hello friends, today we are going to learn about the topic virtualization technologies Hyper-V, in which we are going to learn about its architecture, advantages, disadvantages and features. Hyper-V technologies. Hyper-V 3.0 or Hyper-V builds an older version of Hyper-V which creates a virtualized environment for multiple partitions to run. The hypervisor layer on the parent partition enables the management of child partition. Hyper-V uses the term partition to refer to a virtualization layer that provides an independent, isolated environments in which guest operating systems and applications can run. See, here what they want to say is that there is one physical resource. With Hyper-V, we have a parent partition again of virtualization. Then again, now this Hyper-V enables management of child partition. This is the parent partition. It has various child partitions. So this hypervisor layer here, it helps in the management of these child partitions over a parent partition. Hyper-V uses the term partition here to refer the virtualization layer that provides an independent, isolated, see, this is independent and isolated, in which guest operating system and applications can run. See, it has this independent and isolated environment in this guest operating system as well as applications can run. Distinguishing itself from previous iterations of the hypervisor, Hyper-V has an extensible virtual switch which affords advanced networking features such as extensions that inspect, monitor and sample traffic. Hyper-V also offers live storage migration, in which a step up from Windows Server 2008 R2's quick storage migration does not require periods of downtime. It is also capable of migrating virtual machines without shared storage. Hyper-V is built to be scalable. It can support more than 32 nodes and 4,000 virtual machines. See, now what it is saying here is that hypervisor or previous versions of hypervisors, they had something like extensible virtual switches and etc, but the newer versions which are coming, or hypervisor Hyper-V, it has an extensible virtual switch. Now what this extensible virtual switch can do, it affords advanced networking files such as the extension ext files that can inspect, monitor and sample the traffic coming through the way. Then again, Hyper-V, it also offers live migration. What is live migration? That means during the process time or when the particular machine is working, then also it can be migrated from one physical resource to another physical resource, or one environment to another environment. Then it is also capable of migrating virtual machines without shared storage. That means the virtual machines which are isolated, which do not have a shared resource, can also be migrated using Hyper-V. Then Hyper-V is built to be scalable. Scalability is one of the major quality of cloud computing. It can support more than 32 nodes, that is the capacity of Hyper-V, and 4,000 virtual machines. Microsoft Hyper-V, codenamed Viridian, formerly known as Windows Server Virtualization, is a native hypervisor. It can create virtual machines on x86-64 systems running Windows. That means now, since we know Microsoft's Hyper-V, it can or it will be working on particular architecture which will be running Windows on itself. Starting with Windows 8, Hyper-V superseded Windows Virtual PC as the hardware virtualization concept of the client solutions of Windows NT. A server computer running Hyper-V can be configured to expose individual virtual machines to one or more networks. Hyper-V was first released with Windows Server 2008 and has been available without additional charge since Windows Server 2012 and Windows 8. A standalone Windows Hyper-V server is free but with command line interface only. That means there are some of the limitations that it can be available there with command line interfaces only. Hyper-V 2008 or Hyper-V Server 2008 was released on October 1, 2008. It consists of the Windows Server 2008 server core and Hyper-V role. Other Windows Server 2008 roles are disabled and there are limited Windows services existing there now. Hyper-V Server 2008 is limited to a command line interface used to configure the host operating system, physical hardware and software. A menu-driven CLI interface and some freely downloadable script files simplify configuration. In addition, Hyper-V Server supports remote access via remote desktop connection. However, the administration and configuration of the host operating system and the guest virtual machine is generally done over the network using either Microsoft Management Consoles on other Windows computer or System Center Virtual Machine Manager. This allows much easier point and click configuration and monitoring of the Hyper-V server. Hyper-V Server 2008 R2, an edition of Windows Server 2008 R2, was made available in September 2009 and includes Windows PowerShell v2 for greater CLI control. Now here they are saying that the Hyper-V Server 2008 R2, which is for Windows, designed for Windows Server 2008 as we have been seeing now. So this was made available in September 2009 and what it includes the Windows PowerShell v2 for the greater control of command line interface. Remote access to Hyper-V server requires command line interface configuration of network interfaces and Windows firewall. Also, using a Windows Vista PC to administer Hyper-V Server 2008 R2 is not fully supported. Hyper-V implements isolation of virtual machines in terms of a partition. Now, see, as we all know, Hyper-V provides the isolation of the virtual machines. It can be a standalone system. There will not be any shared storage. So it provides incomplete isolation. Here Hyper-V implements isolation of virtual machine in terms of partition. We have the parent partition, then we have child partition to that parent partition, all these things. Now a partition is a logical unit of isolation supported by the hypervisor in which each guest operating system executes. That means, see, this is your parent partition. It has the hypervisor in between and then it has several child partition. And this is over physical resource. So now what it says is each of the partition, child partition which we have, that is 1, 2, 3 and 4, all of them are a logical unit of isolation. It is supported by hypervisor in which guest operating system executes. That means guest operating system executes in this only virtual machine, and then this virtual machine has its own guest operating system, this has its own, and this has its own. That means each machine has its own guest operating system. There must be at least one parent partition in a hypervisor instance, as we have seen here, running a supported version of Windows Server 2008 or later. The virtualization software runs in the parent partition and has direct access to the hardware devices. The parent partition creates child partition. We have seen this is the parent partition. It creates again child partitions which host the guest operating system. That means the guest operating system get executed on these child partition. A parent partition creates child partition using HyperCall API, which is the application programming interface exposed by HyperV. Now, we have seen this is the parent partition, and then this hypervisor here, it creates child partition. So how these child partitions are created? Thus, this hypervisor here, it uses the HyperCall API. What is API? API is application programming interfaces. With the use of this, it creates child partitions over one parent partition. Now, these APIs are exposed by Hyper-V. A child partition does not have access to the physical processor, nor does it handle its real interrupts. That means, see, we have this parent partition, then hypervisor, then child partitions here. So this child partition do not have any access to the physical processor or physical resources, hardware resources, whatever we can say here. Neither does it handles the real interrupt. Real interrupts, that means the interrupt which occur in the real time or the physical system. Instead, it has a virtual view of processor and runs in guest virtual address. We have seen there in virtualization of the memory and CPU and devices input output, which depending on the configuration of the hypervisor might not necessarily be the entire virtual address space. Now see, the guest virtual address which is being assigned to that particular virtual machine which is in the child partition will depend on the configuration of the hypervisor and will not be exactly existing in the virtual address space. Depending on the virtual machine configuration, Hyper-V may expose only a subset of the processors to each partition. The hypervisor handles the interrupts to the processor and redirects them to the respective partition using a logical synthetic interrupt controller, or you could say sync IC. Hyper-V can hardware accelerate the address translation of guest virtual address spaces by using second level address translation provided by the CPU, referred to as EPT on Intel and RVI, formerly NPT on AMD processors. See, this is the child partition and parent partition of Hyper-V. We have this hardware, then this is the hypervisor. It is in ring 1. Then going to ring 0. Ring 0 is kernel mode. It has this VM bus here in parent partition as well as in child partition. Then this VM bus, it is connected to device drivers. These device drivers have virtualization service providers, VSPs, and then Windows kernel. Again, VM worker process here it does, and then it creates or it goes to virtual machine management service and then VMI provider. Now coming to the child partition of that particular parent partition. So child partition, it starts with VM bus, which is in kernel mode ring 0. Then it has virtualization service consumer and Windows kernel. Then the applications which are installed in this, it is the user mode, which is in ring 3 at the least priority. Child partitions do not have direct access to hardware resources, but instead have a virtual view of the resources in terms of the virtual devices. Any request to the virtual devices is redirected via the VM bus to the devices in the parent partition, which will manage the requests. The VM bus is a logical channel which enables inter-partition communication. The response is also redirected via VM bus. If the devices in the parent partition are also virtual devices, it will be redirected further until it reaches the parent partition, where it will gain access to the physical devices. See here, what they want to explain is, as we have seen in the figure, child partitions, they do not have direct access to the hardware resources we have seen there, but instead they have a virtual view of the resources. Virtual view of the resources, that means the view that is provided to them via partition or parent partition. In terms of virtual devices, now any request to the virtual device is redirected via virtual machine bus or VM bus, as seen in the figure, to the devices in the parent partition, which will manage the request. Now again, that VM bus is also a logical channel which enables inter-partition communication. See, we have this parent partition and then we have this child partition. So with this one child partition, whatever communication is done via VM bus and is a logical channel which enables inter-partition. That means parent partition and child partition, or child partition and child partition communication. The response, whichever request is made, it will get a response, and that response is also made via VM bus only. So if the device in the parent partition are also virtual, that means if this parent partition is also virtual and not physical, then it will be further redirected until it reaches the physical resources or parent partition, where it will gain access to the physical devices. Parent partitions run virtualization service provider, that is VSP, as we have seen in the diagram, which connects to the VM bus and handles device access requests from the child partitions. Child partition virtual devices internally run a virtualization service client which direct the request to VSPs in the parent partition via the VM bus. This entire process is transparent to the guest operating system. That means now this communication process via VM bus to the parent partition to the physical resources, all these things, they are transparent to the guest operating system. Virtual devices can also take advantage of Windows Server virtualization feature named Enlightened Input Output for storage, networking, and graphics subsystem, among others. Now, Enlightened Input Output is a specialized virtualization aware implementation of high-level communication protocols like SCSI that allows bypassing any device emulation layer and takes advantage of VM bus directly. This takes, or I could say, this makes the communication more efficient but requires the guest operating system to support the enlightened input-output. Currently, only the following operations support enlightened input-output, allowing them therefore to run faster as guest operating system under HyperV than other operating systems that need to slower emulated hardware. First one is the Windows Server 2008 and later. Second one, Windows Vista and the later versions of it. Then Linux with a 3.4 or later kernels, FreeBSD, etc. Then comes the system requirement for Hyper-V. See, the Hyper-V role is only available in the x86-64 variants of standard enterprise and data center editions of Windows Server 2008 and later editions, as well as the Pro Enterprise and Education editions of the Windows 8 and the later versions of it. On Windows Server, it can be installed regardless of whether the installation is a full or core installation. That means we can install this Hyper-V regardless whether the installation is full installation or the core installation. In addition, Hyper-V can be made available as part of the Hyper-V Server operating system, which is a freeware edition of Windows Server. Either way, the host computer needs the following requirements. Now, the following requirements which are required here by Hyper-V are CPU with the following technologies, that is NX bit, x86-64, hardware assisted virtualization. We have been discussing this x86-64 since a long time. Now what is this x86-64 here is x86 architecture with 64 bits. Hardware assisted virtualization, it can be Intel VT or AMD V. Second level address translation in Windows Server 2012 and the later versions of it. At least 2 GB memory in addition to what is assigned to each guest machine. The amount of memory assigned to the virtual machines depends on the operating system. Windows Server 2008 standard supports up to 31 GB of memory for running virtual machines plus 1 GB for the host operating system. Windows Server 2008 R2 standard supports up to 32 GB, but the enterprise and data center editions support up to 2 TB. Hyper-V Server 2008 R2 supports up to 1 TB. Windows Server 2012 supports up to 4 TB. The number of CPUs assigned to each virtual machine also depends on the operating systems. Windows Server 2008 and 2008 R2 support 1, 2 or 4 CPUs per virtual machine. The same applies to Hyper-V Server 2008 R2. Windows Server 2012 supports up to 64 CPUs per virtual machine. These are some of the system requirements we have been studying so far for Hyper-V technologies or virtualization technology. Some other are, there is also a maximum for the number of concurrently active virtual machines. They are Windows Server 2008 and 2008 R2 support 384 per server. Hyper-V Server 2008 supports the same amount. Now here Windows Server 2012 supports 1024 per server. The same applies to Hyper-V Server 2012. Windows Server 2016, it supports 8000 per cluster and per node. Limitations of Hyper-V are: programs that depend on a specific hardware will not work well in a virtual machine. For example, games or applications that require processing with GPUs might not work well. Also, applications relying on sub 10 ms timers such as live music mixing applications or high precision times could have issues running a virtual machine. In addition, if you have Hyper-V enabled, those latency sensitive high precision applications may also have issues running in the host. This is because with virtualization enabled, the host operating system also runs on top of the Hyper-V virtualization layer, just as guest operating systems do. However, unlike the guest operating systems, the host operating systems is special in that it has direct access to all the hardware. Since host operating system running on a host machine, it will have the direct access to all the hardware, which means that applications with special hardware requirements can still run without issues in the host operating system. See, since it has direct access to the hardware, it can get any of the hardware requirement for any specific task to be performed by the application. Thus, it can run without any issue on host operating system. Thank you.